Alright, today we will be covering Lesson 9-2, Slope and Rate of Change. This lesson will be broken up into 3 separate sections. The first section will cover Question 1, Question 2, and Question 3. Let's go ahead and take a look at the introduction of Question 1. It says, the rate of change for a function is the ratio of the change in y, the dependent variable, to the change in x, the independent variable. Margot went to the lumberyard to buy supplies to build the wheelchair ramp. She knows that she will need several pieces of wood. Each piece of wood costs $3. Write a function f of x for the total cost of the wood pieces if Margot buys x pieces of wood. Well, it told us to name it f of x, and we know that for each piece of wood, which they call x, it's going to cost us $3. So we would do a multiplication here to find out how much we have to pay. It says, make an input-output table of ordered pairs and then graph the function. So we know that if we buy 0 pieces of wood, it costs me $0. If I buy 1 piece of wood, it's going to cost me $3. If I buy 2 pieces of wood, that costs me $6 because 3 times 2. 3 pieces of wood cost me $9. 4 pieces of wood would cost me $12, and 5 would cost me $15. So we're going to see this line oops, my bad. It's a good thing I didn't graph those because I wasn't paying attention. Notice that it counted by 2s and I wasn't paying attention. So we go 3, 6, 9, 12, 15, and so on. So I'm going to plot this kind of similar to this. So it should be along these lines right here. Okay, let's take a look at C. What is the slope of the line you graphed? Well, it looks like it went up 3 units over 1. So my slope is 3. But how much does the cost increase for each additional piece of wood? $3, because that's what the problem told us, that each piece of wood costs 3. How does the slope of this line relate to the situation with the pieces of wood? The slope is the same thing as the cost of each piece of wood. The slope is the same as the cost of each piece of wood. Is there a relationship between the slope of the line and the equation of the line, and if so, describe that relationship? Yes. The slope is the coefficient, that's the number in front of the variable. So it's the coefficient of the variable x in the equation of the line. No debriefing question for this section, so on to number 2.